Hi, my name is Phil Winder, and I'm going to take you through a demo of Pachyderm and Seldon core. So just to give you a quick recap, Pachyderm is a data science platform that combines data lineage with end-to-end pipelines, and Selden core is an open source platform for developing and rapidly deploying machine learning models. The purpose of this demo is to highlight the use of Pachyderm's S3 gateway, which is a really cool feature that Pachyderm exposes. It's basically an S3 compatible API that other people and other products and other services can consume and use as if it was connecting to an S3-like source. The beauty is that is fully version controlled within Pachyderm. So what we can do is we can ingest some data, build a pipeline to train a model based upon that data, output that artifact back to a Pachyderm repository, and then expose it via an S3 gateway. And then the idea is that Selden core can then spin up an sklearn server or equivalent for whatever model you're using, ingest via S3 or via the S3 gateway, and basically use a properly version controlled set of model parameters. So I'm going to take you through what this looks like. I've got a couple of prerequisites that I need to take you through first. We need a fully configured Kubernetes cluster. So for this example, I'm using Kind on my desktop. Any other Kubernetes, local Kubernetes version should work, and any other real Kubernetes cluster should also work. You should also follow the instructions to install Selden core. Instructions are in the are in the usual place. Just read the Selden core docs. I expect you to have curl installed, and also you've downloaded Pachyderm's pachyctl binary, again following the official documentation. Just download it to your desktop. This will allow you to deploy Pachyderm. So first I'm going to run a couple of commands to make sure that we are working and operational. We've got the pachyctl version is 11.8. Should work with versions after this version as well if you're viewing this video in 1,000 years time. And I'm just making sure I've got connectivity to the Kubernetes cluster. Okay, so first we need to install Pachyderm. We do that by creating a Pachyderm namespace and using the pachyctl command to deploy a local configuration. Local in this sense means your local kubectl, your local kube config. It's just going to use the details that are currently loaded into your kube config to deploy Pachyderm to. There's other options here to deploy to Pachyderm Hub and various cloud vendors and things. I'm not enabling the dashboard because I'm just trying to save CPU and RAM on my machine. It's quite an old Mac laptop, and we're deploying into the Pachyderm's namespace, and I'm not exposing the Docker socket just for security purposes. Okay, so I've run that command a couple of seconds ago, and it's gone ahead and created all of the resources, and now it's going to wait until it's deployed. Right, so I'm just going to go into a separate window now and just check on that deployment, because that is taking some time. Okay, and that has finally rolled out, and Pachyderm is now ready to continue. So first, I am going to add the training data to a new Pachyderm repository. So this is using the create repo command on the pachyctl binary, and then I'm going to copy a file over from the example directory. So if I just flick back a second, so this is in the Selden core /examples/ Pachyderm simple directory. Inside here we have a data directory, and that's where it's just copying some CSV data from. And then I'm just going to list to make sure that the repo has been created. It has. It's 4 kilobytes big, massive. And then we're just going to list the data inside the master branch of the training repository, and you can see my iris.csv file is there. Next, I'm going to create a Pachyderm pipeline. And to do this, I'm going to leverage a pre-built container. This will be available hopefully on Docker Hub, but it is in the repository under the Iris train Python SVM directory if you need to build it yourself. it's going to, just inside that, in fact, let's just have a quick look. Inside this container is a little bit of Python code to read in the input data, to read in where we want to save the final artifact, model artifact, and then a little bit of parsing code for the iris data, and then a simple logistic regression model. Okay, so let's go back to this. All right, so that's that container. We're passing in our data here, our training data, and this PFS directory is a special directory that Pachyderm mounts from a specific repository. So we're basically telling Pachyderm, when you run this pipeline, mount the training repository, and it'll default to the master branch, and mount it in the root of the PFS directory. Okay, and we're also mounting the out directory. Writing to the out directory, which will write back to Pachyderm in a respective repository, as we'll see in a minute. So I'm just going to go ahead and run that. So that's just written that pipeline definition, and then I'm going to create the pipeline. So this is now using the packtl command to ask Pachyderm to create and run that pipeline. This pipeline, according to this definition, you can change it obviously, but according to this definition, this pipeline will run whenever there is new data in the repository. And because this is the first time that we have run this pipeline, we should see that the list pipeline commands returns with the pipeline when it finally decides to return. There we go. And the status is that the job, the pipeline is starting, and the last job, so this is the most recent run of a pipeline, is also still starting.
So I've just done a bit of debugging. My cluster was a bit broken, so I just had to fix that. And then rerun these commands, and now we can see that the pipeline that we created has started, run, and now has finished. You can see the job with the list job command, and you can see, well, there you go, that's the results. Now, you know we were writing to the output directory in the PFS folder, so that has automatically created a new repository for us under the same name as the pipeline. So now if we look in the model repository, so if you look, I named it model here, in the master branch, you'll see that we've now got this model.joblib file. So joblib files are the sort of semi-default output format for sklearn style models. They can contain pipelines and things like that. And so basically now we have a fully trained model in version control that we can leverage in Selden Core. So next, first what we need to do is, remember we've already deployed Selden Core, so that's up and running. But what we need to do is we need to provide a secret in the, is that going to go to the right namespace? Oh, I can't remember. It goes to the default namespace. But anyway, we need to provide a secret to access S3. And because this isn't proper S3, we need to pass the AWS endpoint URL, which is pointing to the PACD service. It's important that you make sure that you point it to the right port and the right service. So this is the PACD pod, the PACD service in the Pachyderm repository on port 600. That's where the S3 gateway is exposed. I have not enabled auth on Pachyderm, so the secret and access keys are not used, but you do need to pass something. So I've just passed some random string there. All right, so let's create that secret in the default namespace. And finally, I'm going to create a new Selden deployment. And this is a standard sklearn server type implementation. I've passed in the S3 URL, or the S3 URI, sorry, pointing to the, I think that's the wrong file, isn't it? So it's saved, it's now a joblib file. Whoops, so let's change that. Oh no, sorry, that's right. So this is pointing to the directory of the location of the model.joblib file. That's right. And the directory, or the bucket name in this case, if you remember, it's in the root of the repository. So it's also in the root of the bucket. So I'm just going to pass the bucket, and the bucket name is built from the branch name here. The branch name and the repository name. So we've got master.model because we're looking in the master branch for the model repository, and the file is kind of just here. But for this implementation, you just need to pass the directory where the joblib file is contained. Also passing the secret that we created to access Pachyderm, and yeah, that's it. So let's go ahead and deploy that. Okay, so I've now created that deployment, and now we just need to wait a couple of seconds for that to deploy. Okay, so my deployment is finally completed. It took a minute to download all the containers, and I've also port forwarded the Selden API. Well, actually, sorry, I've port forwarded the ambassador ingress gateway ingress controller so that I can access the Selden API. And we're in the default namespace, and my model is called Pachyderm Learn, and then this is the API that the container exposes. And if I call the predictions endpoint with a little bit of data, you see we're passing in 4 values here corresponding to some the 4 dimensions of the iris data, then we get a result back, 95% confident that it's class 0. Okay, good stuff. As a little bonus though, what we can do is we can automatically rebuild the model. So imagine that you've got some new data. I'm now going to put some new data and overwrite the old iris data with some new data, which if you look at this file, then it's basically the same file but with loads of data cut out. So I'm writing that new data to Pachyderm, and then I'm going to list the data again, and hopefully you'll see that the data has changed. I think if we just double check the sizes of the iris file there, you'll see that it's just a bit different. Where has it gone? Here, so you see it was 4 kilobytes before, now it's 5, so it is slightly different data. I'm listing the Pachyderm jobs again, and you can see that 19 seconds ago we got a new job started, and that's because the pipeline saw that the data had changed in the training repository and automatically ran the new pipeline, which means it's automatically going to rebuild our model. Now in this demo, all I'm going to do is just manually delete the old deployment and apply the new deployment. And when I do that, you'll see that a new model is created. So I'm just going to give it a couple of minutes to run that pipeline, finish that pipeline, and then redeploy the model. Okay, the model is finally redeployed, and I'm now going to call the endpoint again. So it's the same URL, but this time we're going to get a different response because we are now querying the new version of the model. You can see that the probability estimate for class 0 has changed. Before it was 95.5, now it's 96.2. And that's because the underlying training data has changed, so the probability distributions have also changed. Okay, that's it for this demo. In future demos, I'm going to show you how to automate this process end to end. So we have lineage all the way from the training data all the way up to the deployment. And if you're interested in talking to me about this, then my name's Phil Winder, and you can check out winderresearch.com to find out more stuff about MLOps and Selden and Pachyderm. All right, thank you very much. Goodbye.